So in this video I'm going to continue with the recap and do joints and a quick bit on global equilibrium, which has a short example with it. So with joints, there are several different types of joints. There's internal and external joints. So I'll start with internal joints. So internal joints. These are things like cables. So you could have, let's say, you have a cable coming down and then a beam here. So this is a cable joint here. What this looks like in a free body diagram is literally you have the beam and then the force going in the direction of the cable. So that's the tension force. So that's one of them. I'll just label that cable. And then another is just internal pin joint, which is the more standard one that is used in almost every one. It could be something like so. That's the pin joint there. So a free body diagram of this looks. I'm just going to draw it on this one here. So it's just split up into x and y components. So it's r, x, r, y. Okay. So they're the two internal joints that you'll see most. And so external joints are the more ones you want to concentrate on, because they're where more of the examples or more of the solutions come from. So I'll start off with there are roller joints. So this look like a little triangle with little wheels on the bottom. I'm just going to have that out there. So they only cause force in the direction just up, just perpendicular to the surface. So if we do a free body diagram of this looks like this is the beam. And so this is the RY. It's just one force up. It's not no forces in the x direction. So roller. We also have like a smooth support, which is similar to this. It causes a force in the normal direction, but it looks like this. So if we have a beam, let's say resting on a wall, like that. That's not very good. Beam resting on a wall. So this here is the smooth joint. And so a free body diagram of this looks like you literally just have the normal force there. So again, it's just the force in the one direction. So then we move on to another one that we have is the pin joint. So we saw the pin joint for the internal. It's very similar for the external. It's just so let's say we have this. It's similar to the roller, but we now have force in the x and y direction. So the free body diagram of this looks like that's r, x, r, y. So this is the most common one that you'll see in questions. So the last one that is very common as well is a cantilever beam. Essentially a beam just fixed to the wall like this. So these ones can support moment in the x and y direction. They can support forces in the x and y direction, but can also support moment. So they can have a reaction moment that opposes any moment that occur on this beam or something like that. So a free body diagram of this is you have the moment and you have the reactions the RX, and the RY. That's the beam. So that's good to know. So they're the external joints that you'll see.